In the first 3 videos, I trust I've convinced you of the need for good communication skills, and I've outlined key aspects of the course. Now we'll look at something you might think you already know how to do, and you'd be right. You've been doing it since you were about 4 or 5 years old. You've been reading. But reading for science is not the same as reading about Harry Potter or Richie McCaw or whoever. For a start, you can't choose whether or not to read. If you're a scientist, you have to do a lot of it, and a lot of it will be hard going. Therefore, you must learn how to read efficiently. Now, you should pause the video and pull up the document, How Knowledge is Made in Science. It's on stream in the Week 1 block. Scientific literature can be classed as primary, secondary, or tertiary. Primary literature is where scientists present the results of their original research. Often they'll present this in a preliminary form at a conference, and this presentation usually ends up as a paper in the conference proceedings. At this stage, though, the research has not been through a rigorous peer review process. However, in the next step, the scientists write up the research for publication in a peer-reviewed science journal. The editor checks it to make sure it's appropriate for that journal, then sends it to several anonymous referees, often 3, who are well qualified to assess the quality of its science. The referees independently assess the manuscript and report back to the editor. The editor then sends the reports to the authors, along with instructions about what the authors must do before the manuscript will be accepted for publication. Often, though, the manuscript is simply rejected. Getting a paper accepted for publication by an internationally respected science journal is tough, but it's intended to ensure only high-quality papers get published, and that's why a paper in a high-quality, international, peer-reviewed journal is considered the gold standard of scientific literature. Secondary literature comprises review articles. These are usually written by senior scientists, the key researchers in that field. These review articles draw together the primary literature from a field. They summarise the consensus and identify controversies, debates and unanswered questions. They'll often assess trends in the research and identify areas that deserve more attention. They're excellent for anyone just beginning to investigate a new field. Finally, tertiary scientific literature is where journalists and science communicators translate the often highly technical primary and secondary literature and communicate it to non-expert audiences in the form of articles in popular science journals, books, feature articles in newspapers, blogs, and so on. Another form of tertiary literature is the material disseminated by extension scientists to industry, for example, to farmers and orchardists. All these types of literature are important, and you must learn to discriminate them. You need to know how to find quality sources and to read them efficiently. The crucial type, though, is the peer-reviewed journal article. The quality of the secondary and tertiary literature depends on this.